Proceed in summation to integral. Okay, we are continuing discussion summation to integral. Can we compute our problem solution? Can we get solution to our problem through summation? So that is the concept that we are pursuing, and this concept is heavily used in probability and statistics. In fact, probability and statistics, there are two reasons. If people anyone read it, then there are two reasons into it. One is called discrete reason, and one is called continuous reason. Discrete region has a function and continuous region has a function. Okay, in some fashion, they are some terms they are related to each other. Like in discrete fashion, like binomial distribution, Bernoulli distribution, and this kind of thing comes into the picture. Whereas if we talk the continuous, then normal distribution or Gaussian distribution they come into the picture. Anyway, what is relationship between the discrete and continuous? We have talked about what is discrete and what is continuous. Concept is if I have a problem, I sample the problem into many parts and then solve the problem in many parts. Means idea is to solve a problem into many parts. Okay, like we started calculating the area of a circle, and if this is the radius, then radius will proceed like this, and it will make angle will change. In that fashion, we sample the circle into many parts, and then calculate the area of each part and add it. That's it. Okay, this is called finding the solution through summation. You calculate the value of one part, and then add it. Okay, what is the volume of this sphere? If I'm talking, what is the volume of this sphere? Okay, in that fashion, how I can chop? What is the volume of this sphere? Not the surface area of the sphere. What is the volume of this sphere? Okay, if someone talks about volume of a sphere, let's talk in kind of, if I talk in a Cartesian coordinate system, then I have to chop it into like this, then like this, and then like this. Okay, this is x-axis, along y-axis, and along z-axis. Now I have chop it n times, chop it n times, and chop it n times. Now that will pursue there will be a small section will come in this sphere, and the count of section will be n into n into n. Okay. Now consider the volume of any section. Volume of any section, that is I, j, and k. Volume of any section that is denoted by I, j, and k. Okay, summation I equal to 1 to n, summation j equal to 1 to n, summation k equal to 1 to n. Okay, volume of the section that is denoted by I, j, and k. Volume subscript bottom right I comma j comma k. Ith, jth, and kth section, if I cut in this manner, then if I add all the volume that are the number is n into n into n, I have divided into n into n part, and then if I add it like that, then it also gives the well volume. Means volume is something. What is the volume of ith part? That is debatable. What is the volume of ith part? That is debatable. If it is a Cartesian coordinate system, probably we would say the volume of the ith part is delta xi, delta yi, delta zi, where delta x is the length. If I chop x-axis in n part, one length is delta x, ith section is delta xi. Along y, this is along up, this is along x-axis, and this is along y-axis. Then one section width is delta yi. If I chop along z axis, then one section width is delta zi. Okay, I can say that the ith volume is delta xi, delta yj, because I have taken j as summation, delta yj, and delta zk. Number of sections that we see is n to the power 3. Because if I chop like this, then there are n sections. If I chop like this, n, then there are now n square sections. And if I chop like this, then there is n to the power 3 section. One section can be represented as volume. Volume of one particular section can be represented as volume of the ith, jth, and kth section, where now we have triple summation I equal to 1 to n, j equal to 1 to n, k equal to 1 to n. Triple summation volume of the I, j, and kth section. Okay, someone can say that volume is actually delta xi, delta yj, and delta zk. Okay, we can go with the spherical coordinate system also, because here things would be a little different. I can go with the spherical coordinate system. What is a spherical coordinate system? Spherical coordinate system is there are three variables in a spherical coordinate system. One is theta. If people know about the spherical coordinate system, there are three variables in the spherical coordinate system. One is theta, that is on xy plane. One is phi, that is on zx plane or zy plane, or hybrid zxy plane. What is zx plane? What is zy plane? And what is z and xy plane? If this is x-axis, this terminology should be very clear. Okay, all the problem we see in the calculus, all the problem we see, okay, they get solved into these coordinate system only. That's why we give this much emphasis on coordinate system. Any problem finally needs to be drawn pictorial in a graphical manner. Any problem, then only people understand. Okay, I am doing a summation where y is greater than x square and less than 1. Okay, integration of y greater than x square and less than 1 and something fxy dy, like in marginal distribution. There are many kind of integration we do. One integration is called double integration, one integration is called single integration, one integration is called triple integration, one integration is called marginal integration. Many people would not have heard about it. Marginal integration. Many people talk about the conditional integration. There would be others also. Everywhere, it someone can be accurate only when he understands the pictorial view of it. Then only he understands. And pictorial view cannot be clear if the person does not understand the coordinate system. So clarifying any problem through coordinate system and then forcing any reader to visualize it, that is very much important. If I say my integration sign y equal to x square to 1, what it means? I'm trying to integrate something fxy. I'm trying to integrate fxy dy. Makes sense? Function over x and y. What is function over x and y? If this is x axis and this is y-axis, then this plane, what the plane we are talking here, this plane is xy plane. This is xy plane. Function over x and y. If I choose any point on this xy plane, this xy plane has so many points here called x comma y. If there is a function over x comma y, then I always say like that, if I have a Python function, any function where we insert x comma y, it will return output. If I insert x comma y, it will return output that will be a number or something like that. So if I put any x comma y scalar value, numeric value into a function, it will return a height. Means at this x comma y, what are the height points? If I connect all the height points, it will give a 3D shape. Anyway, fxy, function over x and y. That is the height at any point. That's why I say pictorial representation is very important. Generally, people understand, okay, how to solve this problem, mainly to crack some examination. So pictorial representation is important when real life use case comes into the picture. So fxy dy, fxy dy, what it means, we will talk later. What it means fxy dy, fxy dx. I'm not talking about fxy dy dx. fxy function over x and y, dy function over x and y, that is the height on the xy plane. Fxy function bracket x comma y bracket close, function over x and y, fxy dy, fxy dx. These are called marginal integration. Okay, fxy dy dx, this is called volume integration. This is typically called double integration or calculation of the volume. Fxyz dy dx dz. This is typically called weight integration. It will give you the weight from the density, that is fxyz. Okay, f f fx dx. This is typically called area calculation, single integration, double integration, triple integration. What about a marginal integration? Fxy dy, fxy dx. Okay, what about fxy by fy dx? Hop. Fxy by fy, function over y, function over x comma y, by function over y dx, integration of x from one limit to another limit, function over x and y by dx, I'm sorry, function over x comma y by d by fx, function over x comma y by fx. Okay, dy. If I do like this, these are typically called the conditional integration. Up. These are typically called conditional integration. Okay, so fxy by fy dx, fxy by dfx by fx dy. These are called conditional integration. Anyway, if I am integrating something where limit is y from x square to x, what it means? Whatever, whenever we, as we have always said, integration is nothing but multiplication of two items. Whenever we integrate, we finally divide it into only two parts. If I say fxy by fy dx, fxy by fy dx, then fxy by fy becomes gxy. Okay, gxy dx, or fxy by fx dy. If I say like that, then it becomes gxy dx, gxy, another function gxy dx. Now, actually, we are trying to multiply gxy with x-axis, that is gxy dx. We are trying to multiply gxy. If this is x-axis and this is y-axis, then there are many points called x comma y. If there is a gxy, that is a function over any point here as x comma y, gxy is the height. If I integrate this height over x-axis, what I mean, integration of any height along x-axis means I'm multiplying the height along the x-axis. Okay, integrating this height along the y-axis, I'm multiplying this height with the y-axis. We're trying to calculate area. What is gxy or fxy dx dy? We are trying dx dy, I can write as dxy plane. Height into xy plane. This will give the volume. Simple, right? If I say my limit of y is from square root, limit of y is from x square to 1. Okay, what is your limit? If I try to calculate a volume, then I say fxy dx dy. Fxy is the height and dx dy is the xy plane. Height into xy plane area will give the volume. Okay, but what is the limit here? Understood. fxy dx dy or fxy dxy plane will give the volume. Understood. But what is the limit? What is limit here? Then provided you have a limit, what is the limit? I understand that fxy is the height function, and then we have a dxy plane. Then what is the limit? Limit means if this is a sphere, I'm trying to calculate the volume, then this sphere is up. Okay, this is origin. Up. This is origin. And this is x-axis, this is y-axis. Now it is kept like this. Consider this sphere is centered at the origin. The center of this sphere is coinciding with the origin here. Then in that fashion, this sphere is making intersection on x-axis. Actually, this is not very much true. If I'm saying, consider like this, and this is the origin. Okay, now it will go inside, and center of this will coincide with this origin exactly at the middle. Top part is the top hemisphere, bottom part is the bottom hemisphere. If it goes like this on xy plane and center fit at the origin, on xy plane it will make a circular region. Means x and y point what we are choosing to make a 3D, that point must be confined in a circular region. That is called limit. So what is limit? If I calculate the volume of a sphere, then on xy plane, x comma y point, those are called independent points. Those points would be selected from a set of points. Okay, means if this is xy plane, this is origin, and this is x-axis, and this is y-axis, this is xy plane. If I keep like this, then I will select many point here, x comma y, many point here, and at that point I will compute fxy, function over xy. It will give me a height. Every point it will give me the height. If I connect all the height point, it will make a sphere like this. I'm trying to calculate volume of the sphere, then height into d into xy plane will give the volume. Fxy into xy plane, or fxy into dxy plane. If I put d there, to make it integral calculation, I have to specify in what region in xy plane I have to select x comma y. I cannot select x comma y here or here or here. It must be in a region only. That region is the region of the limit. In xy plane, how far x and y being independent component, they can go, they can from origin, they up to what level they can go, or what is the region on the xy plane, that region only x and y value I have to confine. Okay, if I say that I'm trying to calculate the volume of a sphere, and this is the origin, this is x-axis, y-axis, sphere is here, somewhere here. In that fashion, if I do the integration, this sphere is touching the xy plane in some other region. That region x and y I have to take as the limit. Not center will not come at all in the picture. So where, if what is the region where we have to select x comma y, that region is the limit region. I say calculate some integration with dy where y is x square, between x square and 1. What it means? What it means is that y, right now what it means, if I say my limit is a circular region on xy plane with radius a, then integration limit is x square plus y square less than equal to a square. That is a circular region. Or I can also say y is greater than minus a square minus x square and less than square root a square minus x square. Same thing. Okay, it means that if I draw a circle on the xy plane, if I draw a circle, then if this is a circle, then square root of a square minus x square is here, y-axis, and minus square root of a square minus x square is here, plus square root of a square minus x square is here. Okay, in that fashion, it is the y will go from here to here if there is a hidden circle here. if there is a hidden circle here, circle is the limit, circle is the limit, means all the point I select for the integration must lie in the circle. Okay, similarly if I say y is greater than x square and less than 1, it looks like a parabola. Y equal to x square means it is a parabola. On xy plane I am drawing a parabola, and y is greater than x square means if I draw a parabola on xy plane, this is the parabola. Consider this is a parabola, and on xy plane, this is x-axis and this is y-axis. This is parabola. I'm saying y should be greater than x square. This is the equation of y equal to x square. Greater than x square means this region, and less than y equal to 1. Y equal to 1 is a straight line like this. If this is origin, this is x-axis, this is y-axis. Y equal to 1 like this. Y equal to 1 line will be exactly a parallel line to x-axis like this. Means I am talking about a region where this line cuts this y equal to x square. Region between this line and underneath it, but above this line, curve. That is y is greater than x square and less than 1. Whatever you see, whatever we see, we try to imagine as a pictorial diagram. Then only we understand the concept. Okay, like if I'm trying to calculate the volume of a sphere through a summation, then we can do cut in the xyz plane also, that we saw. Summation I equal to 1 to n, summation j equal to 1 to n, summation k equal to 1 to n. Volume of the I, j and k section. If I keep adding all the volume, I have cut it in n part, then I get the volume. Or someone would say it is difficult. Let's try in spherical coordinate system. In a spherical coordinate system, if we see in a spherical coordinate system, if we see, then if this is the sphere, if this is the sphere in a spherical coordinate system, then if I put like this and make it go little down, consider this sphere is centered at the origin. Half of the sphere is above the xy plane, half the sphere is below the xy plane. Now, if I put a ring like this and it will go at the middle, it will go at the middle of it, then this is typically called xy plane. I'm talking about hybrid Cartesian coordinate and spherical coordinate system. If this is at the middle, it is kept on the xy plane, but it is touching all around the sphere. This is this here. If I take a radius, here if I take a radius, here if I take a radius and move the radius like this, then the angle it is moving, this is called theta angle. This is one of the component of the spherical coordinate system. Or if I take this radius in this fashion, because sphere radius will go all along. If I take this radius and it is moving like this is xz plane. This is x-axis, this is z-axis, this is y-axis. Radius is moving like this, then radius is moving in xy plane. It is moving in angle theta. If radius is moving in xz plane, radius can move like this also. Radius is moving in yz plane, radius can move like this also. Or radius is moving in zxy plane, that we had started the discussion. Radius is moving in zxy plane, z and then xy together. Z and xy plane. What is xy plane? This is xy plane. Full is xy plane. This is z axis. Z axis and xy plane means radius will go anywhere. This if this is the center, radius will go like this also. So this is going in z and xy plane. If I see this radius and if I draw angle with the vertical, that is called phi angle. Okay, radius cos phi is the z axis. Radius sine phi will fall on xy plane somewhere. Okay, if I so no, my radius is varying in xz plane, then this is x axis, this is y-axis. Radius will move exactly in xz plane, making phi angle with the vertical. Radius is making exactly in yz plane, making phi angle with the vertical. Radius is moving in zxy plane, zxy plane. This is zy plane, zx plane, and anywhere is zxy plane. Now radius is making phi angle with the vertical. But if I draw in zx plane and radius is moving like this, making phi angle with the vertical, then this radius is r. At any moment r sine phi will fall on exactly x axis. In yz plane, r sine phi will fall on y axis. If I say anywhere else, then r sine phi will fall on xy plane. If it falls on xy plane, then if I do cos theta again, first I did sine theta of the r, sine phi of the r. Then if I do cos theta, then it will come to x-axis. If I do sine theta, it will go to y-axis. Okay, now it is understood that there are three kind of three variables in a spherical coordinate system. One is radius. Radius will start from the origin of the sphere and it will grow like this. Slowly, it will grow like this. If we see theta, then in xy plane, theta will grow like this from 0 degree angle to 2 pi. If we talk about phi, then it will grow in zxy plane. Theta will grow in pure xy plane, whereas phi will grow in zxy plane, not in zx or zy. Zx phi will grow from vertical phi angle. This is the phi angle from the vertical. This is the vertical. Now it is making phi angle, and it will go like this. It will go up to 180 degree. Then it makes complete, and this theta will go 360 degree. If I am talking about calculating the volume of a sphere, this is not available in any of the book. How through repeated summation I can calculate volume of a sphere? If I saying repeated summation, how I can make chop in the sphere that there will be small section I'll get in the sphere. Adding all the sections will give the sphere volume. Okay, first reason to chop it is the radius. So consider that I am chopping the radius. Chopping the radius means if this is the radius, consider there is a sphere and this is the radius. If I chop the radius from here like this n times, means it will give a bigger sphere. If radius first section, if I chop this radius in n part, the first section will make a smaller sphere. Second section will make a sphere which will be if this is the first section whose length is consider radius is a, then one section length is a by n. It will make a sphere with radius is a by n. If I talk about the second section, it will be a sphere whose radius will be 2 into a by n, outer layer. Inner will be a sphere of radius a by n. I believe it is understood. So this is the section I am creating along the radius. I can create a section along the theta also. Means I will chop like this. This is making theta the way we did in the past 2-3 videos. Where if this is a circle, then we chop like this. The radius will chop like this. This is this is this is section number 1, section number 2, section number 3 like this. But along on x-axis, I chop like this. I chop like this. Makes sense? This is chopping in theta angle. If I chop in phi angle, this is the phi angle. From the vertical, it makes phi angle. I chop like this. From here, one section. Then from here, another section. From here, another section. Okay. Now, someone can imagine how it will be chopped like this. Or here on the theta, how it will chop like this. If I chop in radius fashion, if I chop in theta fashion, if I chop in phi fashion, then there will be n into n into n. If I chop n section, there will be n into n subsection I can see. Okay, where volume of each section that we will see. What is the volume of a sphere now? Summation I equal to 1 to n, summation I equal to j equal to 1 to n, summation k equal to 1 to n. Volume of the I, j and kth part. What is this volume? I, j and kth part. Understood what is this volume? Then if I talk about in a radius manner, I belongs to theta, j belongs to phi, j belongs to phi, and k belongs to radius. Consider in this fashion. Then theta, if I talk about the theta, then I have many n section in theta. What about the ith section? Ith section theta width is delta theta I. Delta theta I. If I talk about the phi, the jth section is delta phi j. And if I talk about radius, the kth section is delta rk. Makes sense? Okay, what is the volume then? Is it delta theta into delta r into delta phi? Certainly not. If I talk about this is not available in any of the book. If I talk about, we are talking about how we can compute how we can calculate the solution by bisecting anything into many parts and calculating the summation. So that is the concept. Now, ith part, what is the volume? Ith, jth and kth part, what is the volume? They sum it for I equal to 1 to n, j equal to 1 to n, k equal to 1 to n. If I talk about the volume has three sides. If I talk about the area, then area has two sides. If I talk about the curve length, it has one side. What is the three side of the volume? One side of the volume is radius. How you can say it is radius? Because radius is the length. So ith, jth and kth section of the volume, small volume we are talking, where we cut in radius fashion, we cut in the phi fashion, and we cut in the theta fashion. It makes small, so many volume. Each volume has a length, if I say, then radius cut, that is the delta ri, delta rk, kth section. If I talk about the phi, then if I have a small volume, consider I have a small volume. Where is Mr. Small Volume? Okay, consider I have a small volume. Is it the small volume? I have a small volume. I have a small volume. This is the volume I am addressing. Then consider this is radius. Okay, consider that this whatever we see this is the belongs to phi angle. What is phi angle? This is vertical, and from vertical, what angle we see here, this is phi. And then what angle this it is making in the cut, that is delta phi j, jth section. So this length is belongs to there. Makes sense? I am cutting in phi manner. This is the vertical and this angle is phi. From here I talk about the jth section. This is the jth section where angle between it is delta phi j. Then I'm talking about this length, because if I talk about a small volume, then this length will contribute, and then radius will contribute, delta r will contribute, and then this length from the theta will contribute. There are three lengths. So phi angle will not work. This is delta phi. This is r delta phi. This is, if this is at radius r, then this is r delta phi. Now we have if I talk about the kth section delta phi length, if I talk about the volume, small volume that belongs to I, j and kth section, where I belongs to the ith section in theta and j belongs to jth section is phi and k belongs to the kth section in radius. So jth section phi is whatever the radius at any moment. Radius would vary. Radius would vary from 0 to a. A is the full radius. Any moment we are talking. Consider at this moment radius is r, and we are talking about a volume at this moment. Radius is delta r k, and this is one side of the volume. Other side of volume of this, where the angle with the origin is delta phi j. That is whatever the r we are talking. R will go from 0 to a full. At any moment r we are talking. This angle is delta r delta phi k. What about the third side of this small volume that belongs to theta? If this is up to here is r and this angle is phi, r sine phi will fall on xy plane. Okay, and then theta, if I move, if it falls on xy plane from x-axis, this is x-axis, from x-axis it is making theta angle. Then I move delta theta I. What is this r? That is r sine phi delta theta I. Now we have now repeated summation. Repeated summation I equal to 1 to n, j equal to 1 to n, k equal to 1 to n. volume of the ith, jth and kth, that is r sine phi. At any moment I have taken r, at any moment I have taken phi. R sine phi delta theta I into r delta phi j into delta r k. If I if I go on this, it will come as r square sine phi, r square sine phi, delta theta I, delta phi j and delta r k. Summation from I equal to 1 to n, summation j equal to 1 to n, summation k equal to 1 to n. If I do this big summation, I'll get the volume. Make sense? This is typically called repeated addition. What is here now? Can anyone thinking about it? What is the butter here? What is the meat here? Anyway, nowadays it is very obscene to call meat or something like that. What is the fruit here? Okay, what is the butter here? Here is what we are writing. We are writing summation I equal to 1 to n, j equal to 1 to n, k equal to 1 to n, r square sine phi, r square sine phi, delta theta I, delta phi j and delta r k. Isn't it a similar to r square sine phi is a function over r theta and phi, where theta is missing, but we can write like this. Function over r theta and phi, function over r theta and phi, and delta theta I, delta phi k and delta r j. It is something like theta r, theta phi j plane. Up. There is a one line called x-axis. There is one line called y-axis. There is one plane called xy plane. There is one plane called xz plane, yz plane. There is a one plane called zxy plane. There is a one then xy plane, x-axis, xy plane. There is a one volume called xyz volume. There is one volume called r theta phi volume, and that is here delta theta I, delta phi k, and delta r j. Okay, anyway, what we are trying to solve now. Now we can say I have a function over theta r and phi multiplied by delta theta I, delta phi k, and delta phi j and delta r k. Summation I equal to 1 to n, j equal to 1 to n, and k equal to 1 to n. Now, can someone say what is your n? N tends to infinity. We have divided into so many parts. How I can solve it to get that? Boss, you have to come to integral calculus. But how I know that what will be the limit? What will, because integral calculus means multiplication of two items. Function over something into function over what? Function over x into x will transform into fx into dx. Function over xyz, function over xyz into xyz will be transformed into function over xyz into dxyz. Function over x and y into xy will be transformed xy plane will be transformed into function over xyz xy into dxy. How I can transform into integral calculus? Okay, up to here I brought my solution, and this is crystal clear. That looks like very nice. How I can bring into ith section, jth section, kth section. Now I know the volume. That is function over theta or phi. That is r square sine phi at angle phi. At angle phi. At distance r, where r goes from 0 to a. Phi goes from 0 to pi. And then delta theta I, delta phi j, and delta rk. Now, please watch our 3 to 4 videos prior. There we have clearly said what is similarity between repeated summation and integration. If I have x-axis and I have 0 to alpha and I divide it into alpha part, I have 0 to alpha on x-axis and I divide into alpha section where each section of length 1. If I talk about function over x, but function over x, that sampling I have taken only at integer portion, at x equal to 1, 2, 3, 4, alpha. Means there are alpha fx I have taken. If I add all the fx, it is similar to if I say I equal to 1 to alpha fx, where sampling has been taken at 1 1 in each section, then it is similar to fx dx x 0 to alpha. Makes sense? This is what we have seen. If fx equal to x, if fx equal to x or fx equal to x square, then function at 1 what is x square, function at 2 what is x square, function at 3x equal to 3 what is x square, function at x equal to alpha what is x square. If I add all x, then it will come exactly at fx dx x is 0 to alpha. Someone can try. It will come exactly like that. But if x-axis 0 to alpha, if I divide into n chop, not in alpha chop, n chop, where n tends to infinity, not equal to alpha. In that sense, if I say repeated summation I equal to 1 to n fx at x equal to ith section, this is not same as fx dx 0 to alpha. This is what we have seen. What it then when it will be same? It will be same if my expression is like this. Summation of I equal to 1 to n fx delta x. What is your delta x? Delta x between two sampling. If I have chopped into n part 0 to alpha, each sampling has a width of alpha by n. Whatever the height I take fx, if I multiply with the delta x and then sum it, because it will give the now the strip area rather than summation of height, it becomes summation of strip area. If I multiply each height with the delta x, then summation of all strip area will give the full area, that is integration between 0 to alpha. Makes sense? Now it is summation of I equal to 1 fx at x for the ith section delta xi. It is same as integration x equal to 0 to alpha fx dx. Same thing is happening here. We have fx f r theta phi, f function over r theta and phi, that is r square sine phi, multiplied by the each section volume, that is delta theta I, delta phi j, and delta rk. If that is the scenario where summation is I equal to 1 to n, j equal to 1 to n, k equal to 1 to n, this is a fit case to transform into integral calculus, luckily. Then we can now write f theta f function over r theta phi d of theta r phi, d of theta r phi. Now these three summation will transform into integral into limit sign. What is the limit sign? Limit sign is volume region. When we are saying d theta r phi volume, then full volume region. What is your volume region? Volume region is considered a sphere is nothing. At the origin, a sphere is zero radius. That is the beginning volume. End volume is the full volume. From beginning volume to full volume, that is the integral, that is the limit of the integral. And then f r theta phi and d theta r phi. Theta r phi are at 90 degree to each other. I can write as d theta dr d phi, and f theta r phi will transform into now r theta into r square sine phi, r square sine phi d theta dr d phi. Now this, the region what we talked about, the volume region, I can break into r theta and phi. R is 0 to a, phi is 0 to pi, and theta is 0 to 2 pi. Will it give the volume? Certainly. This is how we proceed in the summation and then getting the result. Now someone can try. R square sine phi, R square dr will become, or sine phi d phi will become minus cos phi. 0 to pi, which will, it will become 2. 2 I can keep outside. R square dr will become r to the power 3 by 3, 0 to a to the power 3 by 3. Now it will become 2 pi 2 a to the power 3 by 3 d theta 0 to 2 pi 4 pi a to the power 3 by 3 is the volume. Means how we started our discussion and where we land up. But be very careful transforming the to the integration. That is the very miniature science is there. Anyway, our channel name is Meaning. That is also this correspond to miniature science only. So their miniature science is there when we transform it. After is life is controllable, controlled fashion. Anyway, this is we will proceed on this other section here. Please do not mind supporting us. Plus 91 is the India country code. 9483160610 is the telephone number. 91 is the India country code. 9483160610 is the telephone